Hi, this is Joe from the Math Perimeter, where I help to make mathematics accessible, engaging, and approachable through various forms of content. Today I will be discussing how to use implicit differentiation. For more information about this topic, please refer to the article linked in the description. The function we will implicitly differentiate is x squared over a squared plus y squared over b squared equals 1. To implicitly differentiate this function, we begin by taking the derivative of both sides, which gives d by dx of x squared over a squared plus y squared over b squared equals d by dx of 1. To differentiate the left-hand side, we will apply the sum rule, and to differentiate the right-hand side, we'll apply the constant rule. This gives d by dx of x squared over a squared plus d by dx of y squared over b squared equals d by dx of 1. To differentiate the first function, we apply the power rule to obtain 2x over a squared. Similarly, to differentiate the second function, we apply the power rule, but since y is also a function of x, we must also use the chain rule. Using these rules, our derivative is 2y over b squared times dy by dx. To differentiate the third function, we use the constant rule, which states that the derivative of a constant is 0. Therefore, the derivative of 1 is 0. Putting all this together, we arrive at an algebraic equation of 2x over a squared plus 2y over b squared times dy by dx equals 0. We now algebraically solve for dy by dx. To begin, we subtract 2x over a squared from both sides, which gives 2y over b squared times dy by dx equals minus 2x over a squared. We now multiply both sides of the equation by b squared over 2y to arrive at a final solution of dy by dx equals negative b squared x all over a squared y. Thank you for watching. I hope you enjoyed the video. Please like and subscribe. Thank you. See you next time.